All right. We want to talk about Boyle's law, and Boyle's law is one of the subtopics under the gas laws. So there are so many laws: Boyle's law, Charles' law, Avogadro's law, general gas equation, which we are going to explain. But today this one is Boyle's law, and I said that one of the best way you can be very good in any subject if you relate it with simple life examples. Now, for example, look at Boyle's law. Now, people just say Boyle's law, but some people are not relating it to some of the simple life examples, simple things like, for example, you have syringe. You are trying to press. There's a liquid inside here. You are trying to press it, and it is blocked. The tip of that syringe is blocked. That is the concept of Boyle's law. That's the concept of what volume and what pressure. Then also, if you are pumping air into a tire, a bicycle tire, you are trying to pump it. That is, we talk about application of pressure and volume. So then why they become harder to push? Like, why can't you use your mouth? Why can't you use, as the more you pump, the more it gets harder. That's a simple concept. So we are talking about behavior of gases when it comes to this. So how gases behave in terms of movement, in terms of volume, in terms of pressure. So that's why that brought about the explanation and teaching on Boyle's law. I want to make it very easy for you to understand Boyle's law. Next class we look at Charles' law. So, but let's be focused on Boyle's law. Now, what is the Boyle's law itself? Boyle's law states that for a fixed mass of gas at constant temperature, the pressure is inversely proportional to its volume. That is, when the volume increases, and when the pressure increases, the volume decreases, and when the pressure decreases, the volume increases. So when you talk about behavior of gases, if the volume increases, then the Boyle's law is telling us that the pressure decreases. That is inversely proportional. Proportionality sign of inverse. Yes, sir. So when volume increases, the pressure decreases, and when pressure decreases, volume increases. That is just Boyle's law. You're talking about behavior of gases there, relating volume and pressure. Behavior of gases in terms of volume and pressure. So in some textbooks, some say when Boyle's law says that the volume of a fixed mass of gas, it can be given mass of gas or fixed mass at constant temperature. Here we are not, temperature is irrelevant here. When the temperature is not included, when temperature is kept constant, the pressure of a gas is inversely proportional to its volume. So, and that is what the Boyle's law is. So the pressure and the volume move in the opposite direction. That's inversely proportional, or inversibility sign. So it means that the log works only when temperature is constant. That is, the amount of gas is fixed and the temperature is constant. The temperature is not mentioned. Temperature is not included in this behavior of gases. So that is the Boyle's law. Then what about some other simple explanation? Like I said some earlier, when you imagine a syringe and you push the syringe and you push air into the syringe, it will be very hard kind of to push, because of the air need to be compressed. So if the air inside is compressed, it will be somehow hard. So the volume decreases while the pressure increases. So the more you apply pressure to remove the air inside the syringe, then the more the volume of the air decreases. So while the pressure while you are trying to apply pressure, you see, you are trying to apply pressure from the syringe and to the tip, then the volume decreases. So when you put the syringe, the air has more space. So it shows that the volume increases while the pressure decreases, so vice versa. Now, what about the mathematical explanation of this word? P equals to what? IV. Pressure is inversely proportional to what? To volume. So if you look at it, cross to the other side, make some formula, introduce the concept. We have P1 V1 equals to what? P2 V2. This is the formula for exams like waec, neco, and JAMB. So for Boyle's law, P1 V1 equals what? P2 V2. The P1 is what? The first pressure, initial pressure. Then the V1 is the initial volume. That's the first volume that I mentioned in the question. While the P2 is the final pressure, and the V2 is what? The new volume, or the final volume. So this is the formula: P1 V1 equals what? P2 V2. Please, chemistry waec, chemistry neco, chemistry JAMB, this is still the formula we are going to be using. And Boyle's law is not just in the theory, because we have seen it in real life. In fact, when somebody breathes in and the chest is expanding, that's the diaphragm, you see that the volume increases while the pressure decreases. Air enters inside the lungs by the pump. The more you increase the pressure of the diaphragm, then the more the volume decreases. So it's like opposite of that. So the opposite is like, as one is increasing, the other one is reducing. Then as the other one is reducing, then the other one is what? Increasing. So volume increases, pressure decreases. Pressure increases, volume increases. So that is Boyle's law in real life. Then it also tells you the relation between volume and pressure and not temperature, because temperature is constant and temperature is not mentioned here. So that is why we have the formula P1 V1 equals what? P2 V2. That's the formula. Now let's look at some examples of a very good example, simple examples of application of Boyle's law. The first one says that a gas occupies 300 cm cube at a pressure of 760 mmHg. Calculate the volume of the gas when the pressure is increased to 1520. The temperature remains constant. When you see something like this and you don't even know you know that this is chemistry, but you don't really know the topic, write out your parameters. You can see a gas occupies what? 300 cm cube. 300 cm cube is the first volume, that's your V1. Then your P1 there is what? 760 millimeter mercury, 760 mmHg. So P1 V1 equals what? P2. Look at from the question, that one's the P2 is there is 1520, while temperature is constant. So the second volume, the final volume is what we are looking for. So we have what? P1 V1 equals what? P2 V2. So our P1 here is what? 760 times 300. You understand? Then our P2 is what? 1520 times what? V2. Make a change of schedule formula. That's, we have 760 times 300 over 1520. So I'll do the breakdown of that. Just a simple mathematics. I'll do the breakdown in the comment section so that you understand. And the answer there is 150. You can even try it by yourself. Make V2 instead of the formula here. You have 760 times 300 over 1520. So that is. Then let's look at the second question. There's another question here. A fixed mass of gas occupies 500 cm cube. That's your first volume at 760 mmHg. That's your first pressure. Pressure 1, volume 1 has been given to us straight in the question. What pressure will the gas exert if the volume is reduced to this? You can see that is the circumference. So our P2 there in the question is not mentioned when our V2 is what? 250. So our first volume 760. Our first volume is 500. Then our first pressure is 760. That's this. You can see. Then our second pressure is what we are looking for. You can see from here. Then our second volume, final volume is 250. 760 times 500, that's 380,000 divided by 250. And the answer there is 1520 mHg. This one signifies what? The P2. So that is that. And look, that is the question. Look at, it's as simple. Then look at the next question. This next question is something you can just solve yourself also. A gas occupies 400 cm cube of a pressure. 400 cm cube of, that's the first volume. Then the second volume, that's V1, P1. Calculate the new volume. That means we're going to calculate V2 when the P2 is what? 380. So stay the same. You can just finish up this one and let us know the answer in the comment box. So that is about Boyle's law. So next class we're going to look at Charles' law. You can see that Boyle's law is just simple. We have P1 V1 equals what? P2 V2. You look for any of the quantities. Anyone might not be given to you, but the three other will be given to you. That's the Boyle's law. But temperature is not included because temperature is constant when it comes to Boyle's law. If you have any other question, please you can just send us a message or type it inside the comment box. We will see it. Thank you. See you in our next video.